Today we're going to continue our topic of volume. Don't forget, volume is how much you fill an object with. So we're going to be looking at three different shapes today: the sphere, the cone, and the pyramid. And what makes these shapes so special is that they only have one base. In these shapes, the shape that you only have one of is your base. Now if you notice, I'm coloring them in, probably backwards, but that's okay. You can see the base of these objects. Sphere is a little bit different, but it still has one base of a circle. So what formulas are we going to use for these? We're going to use the ones that go with volume. So these are the three formulas we're going to be using. So let's do a couple of examples. The first example, a rectangular pyramid. Oh, wait, look at that. It says a rectangular pyramid. And I totally highlighted that in a color that you cannot even see through. Still can't see through it. A rectangular pyramid. So what does a rectangular pyramid look like? Well, let's take our picture from the formula above where it says pyramid. So now that we have what that shape looks like, we know we're going to be using the volume because it asked us for the volume. It actually said how much cubic feet are contained inside. That's kind of our hint that it's volume. So volume equals 1/3 big B times H. Well, big B means area of the base. So we're going to have to look at this a little bit. Our base is a rectangle, because it says rectangular pyramid. So if I look up here, it says the pyramid is 7 inches tall. So that's going to tell me that my height is 7. Now in the pyramid, it says that it's 5 feet by 3 feet. So the area of a rectangle is length times width. So in this case, it's 5 times 3, or 15. So my big B is 15. I'm just plugging things into a formula, which is super nice. So volume equals 1/3. I'm going to need to copy that big B formula down from here, and then copy the height down of 7. So when I plug this into my calculator, and don't forget the trick of second alpha, because I can plug in that 1/3 awfully nice, and a whole bunch of other stuff too later. My big B is 15. And my height was 7. So when I get that, what do I get? 35. So the volume of this is 35. And I have to look back at my units. They're in feet. Don't forget this meters is wrong. So it's going to be feet cubed for my volume. So let's look at the next example. In the next example, I have a basketball. A basketball is a sphere. So let's go ahead and take that picture from above and look at our formulas. So I pulled my formula down, and here's my volume again. So the only real measurement I need for the sphere, which is really nice, is my radius. Don't forget, my radius only goes from the center of a circle to the edge. It doesn't go all the way across. So we might have to make an adjustment if it says diameter, or if they give us the diameter. In this case, we have R equals 4, and my volume formula is 4/3 pi r cubed. So when I plug it in, 4/3 pi times 4 cubed. I'm going to do this in my calculator in probably 2 steps. Actually, I know I'm going to do it in 2 steps. But let's go alpha y equals, and we're going to go 4/3. Now, I'm going to do 4 cubed. I'm not going to do my pi because I like to make sure that I know what it is without pi sometimes. And of course, I always pretty much want my decimal. So let's look. 85.33. So this is equal to 85.33. Don't forget, I did not put in my pi, so I got to add it here. Now, since this is 85.33 and it's already a decimal, I'm going to go ahead and throw my pi in. So I'm going to multiply my last answer by pi, and I'm going to get 268.08. And what are my units on this? Inches cubed. and that's my volume. Now it asks me a new question. It says, how much air could one hemisphere hold? Well, what the heck is a hemisphere? Oh, it's just half a sphere. If I could write and spell, it would be great. Okay, half a sphere is a hemisphere. So if I look, I'm just going to take my volume from here and I'm going to half it. I'm going to half the 268.08 or divide it by 2, which I'll do in my calculator. And I get 134.04. So we just have to make sure that we actually answer the questions that they ask. So let's look at the next example. In the next example, it says a paper cup shown below is filled with water. How much will it hold? Well, they showed us our picture, and it looks like our cone. So if I bring my formula down, it looks just like this one. And let's go ahead and do some work. I know that my volume formula is here. So let's see. Volume equals 1/3 pi r squared times h. And what do I know and what do I not know and all that good stuff. So let's see. First of all, I have the diameter here because it goes all the way across. I want my radius. So my radius is equal to 1/2 of the diameter, or 2.1. So far in my formula, I'm sitting with this right here. I still need my h. Well, h is supposed to hit this at a 90-degree angle, so it looks like it should go right there. But I don't know what that is. I know that half of this is 2.1. The other really, really, really cool fact is look at this awesome shape right here. Anyone recognize what shape this is? That's right, it's a right triangle. How could we ever forget our right triangles, right? I'm going to copy it down right here. And there's some way I could use maybe SOHCAHTOA. If I was using SOHCAHTOA, I would have to pick an angle. There's not really a way for me to pick an angle, so I'm probably not going to use SOHCAHTOA. It really has nothing to do with angles. Is there some formula? That's right. I know c squared equals a squared plus b squared. The Pythagorean theorem. Now what is my c? It's the side across from the right angle, so 5.6 is my c. Now I've gotten pretty good at using this, but I'm going to subtract 2.1 squared on both sides. So I get 5.6 squared minus 2.1 squared equals x squared. Then I would take my square root. So x is going to equal the square root of 5.6 squared minus 2.1 squared. When I plug that in my calculator, second x squared, oh, there we go. I get 5.2 squared minus 2.1 squared. And I just hit enter. What do I get? 4.8. Oh, I made a mistake though, didn't I? Sometimes I wonder about myself. It's not a 5.2, it's a 5.6. So just like you, I make mistakes. But luckily I looked at it because I wanted to make sure all the numbers are right. I try to double check myself. You should always do that. 5.6 squared minus 2.1 squared. And then what do I get? 5.2. Now x was also my height, so that 5.2 goes right here. And I just plug this directly into my calculator. Hopefully this time I don't make a mistake and plug it in wrong. Alpha y equals, enter. And what do I put in? I put in 1/3 times, and I'm gonna actually go ahead and not put my pi in yet again. I know you guys probably hate me for that. 2.1 squared times 5.2. And what do I get? 7.644. Pi, because I didn't type in the number pi yet. And that's centimeters squared, cubed. I don't know why I said squared but wrote cubed. It's cubed. Then when I times it by pi, I get 24.01. And that's my final answer for the volume of this paper cup. Let's look at our last example. For our last example, we have this shape. This is actually a pyramid in Egypt. So if I look, I'm going to need to get my formula for pyramids. So I'm going to bring that over so I have it sitting here. Now the volume of a pyramid is 1/3 big B times H. So volume equals 1/3 big B times H. Well, in this case, what is big B? It's a square pyramid, so it is a square. And if I look, the side of its base, because square pyramid, it's base squared or side squared, I think is what your formula sheet actually says. So I'm just going to take 230.4 and square it to get my area of a base. And I'm going to do that in my calculator. And magically, I get this really super huge number, but that's okay. 53,084.16. And that's going to be my big B. I still need my height, but they gave it to me, so I just plug that directly in. And I'm going to plug this into my calculator. I'm going to use that alpha y equals, so I can plug in a nice fraction, 1/3, and I'm going to multiply it by 53084.16. And I'm also going to multiply it by 146, which is my height, 0.5. So I have my area of my base times my height times 1/3. And what do I get? $2,592,276.48. And my units on this are meters, so it's meters cubed. Go have some fun doing some practice.